looks good, eh? It's XP's new invention. I'm giving him a hand with it. Don't ask me what it actually does, though. He hasn't got round to explaining that bit yet. But he will. See, it all started when I was having a nice quiet rest.
Sarah!
What?
Sarah!
I thought I'd told you to stop doing that.
Doing what?
Well, just dropping in out of the blue. I mean, I thought I'd explained about privacy and knocking first and all of that, and you promised the next time you'd come, you'd go to the front door and ring the doorbell.
But I did.
Well, I didn't hear anything.
No, because the buzzer didn't work.
What are you going on about?
I pressed the buzzer loads of times, but the bell didn't ring.
Oh no, there must be something wrong with it.
Good.
What do you mean, good?
Well, I was thinking of a new investigation. Something to do with crisps, I thought.
Any old excuse to get more packets, eh, XP?
But now I can do an investigation into why your doorbell isn't working. Wait here. Express minus 3, 2, 1.
You don't need the whole door, XP, just the bell.
Ah. Repeat express. Again?
Can take you next door and have a really good look at it. I'd never bothered to take a close look at the front doorbell before. It was in bits. There was a bit that you pressed, the bit that made a noise, and a battery. They were all joined together by some wire.
Well, the button thingy works all right. And the noise thingy works. Must be this string stuff that's not working. What's it for, anyway? To tie the bell to the door with?
No, it's not string, it's electrical wire. Loads of things have electrical wire. It's for the electricity to travel along.
Shrink factor 5. Well, I've had a close look, and there doesn't seem to be any electricity travelling along it. So we found our problem.
Yes, we found the problem, but we haven't got an answer. And anyway, you wouldn't be able to see the electricity. It's invisible.
Well, how do you know it's there, then?
I don't know. Just stop asking difficult questions.
Where does electricity come from?
Yeah, you've got it.
Have I? Where? I can't see it.
No, the electricity comes from here. The batteries must be dead. Wait a minute. There you go, now ring the buzzer.
That is amazing. How does it happen?
I don't know, but I bet we could find out though. Come on. electricity. There we go. Electricity.
Electricity is what we use to work machines like radios, washing machines, and vacuum cleaners. There are two main ways to get electricity.
Pick mains electricity or battery power.
Oh, let's pick the first one.
Okay.
Many things in the home get the electricity they need to work when they are plugged into a socket in the wall. The electricity is made in a power station and is pushed down large cables to people's houses. This electricity is known as mains power. Mains power gives electricity a massive push. This push is so powerful that it can easily kill you. Never experiment or play with mains electricity.
I don't think we should investigate that one, Sarah. It looks dangerous.
Yeah, dead dangerous. Let's try battery power.
A safe way to get electricity is from a battery. Batteries come in all shapes and sizes, from this large car battery to this tiny watch battery. Even the biggest battery hasn't got as much push as mains electricity. But big batteries can still give you a nasty shock. Batteries push electricity round a circuit. If you put something like a bulb in the circuit, the electricity will make it work. You must have a complete circuit to make the bulb light. To turn the bulb off, you could make and break the circuit by pulling out a wire. But a much easier way of controlling the bulb is to use a switch. When the switch is on, the circuit is complete. When the switch is off, it makes a break in the circuit and the electricity stops flowing.
Well, you got enough ideas for an investigation now, XP?
More than enough. What about you?
Oh yeah, same here. I'm going to start some experimenting.
And I'm going to do some investigating.
Well then,
Disconnecting. Investigating electrical circuits. Scan for observations.
Scanning. The switch on this cassette player is switched on. When the circuit is broken, it is switched off. There are circuits in this computer game. The buttons on the front are the switches that control them. This security guard has a circuit in his walkie-talkie. The button he presses is the switch that completes the circuit and makes it work. Warning! He has not seen anyone from another planet before. Suggest you show him you do not mean any harm.
Activate smart specs. What are you on?
Activated. Scanning. This is Greenwich Toy Library. This racetrack has a special switch. When you put the peg in the hole, it completes the circuit and starts the cars. This electric robot has a very large switch. This is so that children with special needs can play with toys that have circuits.
Shrink factor 10. Oh dear. Speed disconnect. Express -321.
I wanted to find out more about which materials let electricity travel through them and which ones didn't. So, I got a battery and made a circuit. Okay, let's see if I got this right. Okay, I think that if I touch these two wires together, then it should complete the whole circuit. The electricity will run out of this end of the battery, along the wire, into the buzzer, making it buzz, out of the buzzer again, back into the wire, round back into the other end of the battery. Let's see if it happens. Yes, my circuit works. Okay, now for the experiment. Instead of touching the ends of the wire together, I was going to touch them to the ends of something else. If electricity passed through it, it would complete the circuit and make the buzzer buzz. It did when I used a fork, so I knew that the fork conducted electricity. So, fork does conduct. I tried a rubber band next. I predicted that it wouldn't conduct electricity. I was right. I predicted the same about a wooden ruler. I was right again. Wood didn't conduct electricity. Next, I tried a copper bracelet. I predicted that electricity would pass along it. And it did. copper did conduct electricity. I tried a 2p coin as well. And that conducted electricity too. Then I got a pencil. It didn't conduct electricity when I tried the wooden part, so I thought I'd test the middle bit of the pencil. This time, it did buzz the buzzer, only not quite as loudly as the others had. Okay, let's just see if I've got this right. The fork, the copper bracelet, the 2p coin and the middle bit of the pencil do conduct, and the rubber band, the wooden ruler and the pencil wood don't conduct. Okay, that's something to show XP when he gets back. Where's he got to?
Activate smart specs. Scan to locate.
Activated. Scanning. You are at the South London Science Centre.
Aha.
This is Paul. He is an electrical model maker.
Hello. I'm from another planet, and I'm investigating circuits. I wonder if you can help me.
Yes, I can. I've got some over here. Follow me.
Great. The thing is, I've seen lots of circuits, but I'm still not sure how they work.
Well, that's because quite often XP circuits are hidden inside the casing and you can't see what's going on inside. In this example, we can take the casing off and we can see that we've got some batteries here. Electricity comes out of here, down this wire, through a switch, and when I press the switch, electricity flows through a buzzer, makes a sound. Electricity continues around back into the battery. The circuit always has to go around back into the battery. On this side we have another circuit. This time it comes out of the wire as before, through a switch, but this time the electricity makes a motor spin round, an electric motor. But again it has to flow through the motor and then back around into the battery. This is another circuit that I've made. This finds out how steady your hand is. What you have to do is you have to move this loop around this bent piece of wire without touching it. And if you do touch it, that completes the circuit and makes the buzzer buzz. Let's just explain how that works. We have some batteries here and the electricity flows down this wire into the bent piece of wire, and then when you accidentally touch it, the electricity can then flow down along this wire and then back through the buzzer and back into the battery.
Paul took XP to where some children were making a whole load of different circuits. There was one where the switch was a clown's nose, so when you pressed his nose, it made his tie spin round.
So that button is a switch, is it?
Then there was a quiz game with questions down one side and the answers down the other.
Can we have a look underneath, see how it works?
Each question and its answer were on a circuit, and when you matched up the question to the right answer, it completed the circuit, and a buzzer went off and a bulb lit up.
So now we've got to think up some questions and answers that link up. For this one we've got some different kinds of nuts here, but of course they're all mixed up. So let's try and find out what this one here is. We hold the wire onto its paper fastener. Let's work our way down. No, it's none of these. It's a pistachio nut. And each of the others, let's find out what this one is. I reckon that might be a peanut. Yes, I'm right.
Then there was a circuit built into a birthday card. When you closed the card, it completed the circuit and lit the lights on the front.
There's a red wire, and that's the plus one, and that goes to the top one that is attached to this and will go on the longer wire side.
Okay, so that top one, that's the plus, and that goes to the long legs, right?
Yeah, and this one is
That's the minus.
the minus, and it goes to the other side.
Okay.
And then when you hold it together, then you complete the circuit and lights will light up.
Wow!
XP had a great time and wanted to find out even more.
Thanks a lot, Paul.
My pleasure.
Bye, you two. Disconnecting. Aha! What have we here? There's the wires. There's the battery, and there's the switch that completes the circuit. What else have we here? Oh, there are the wires, there's the battery, and there is the switch that completes the circuit. Cool. Same again. There's the wires, there's the battery, but no switch. Ah, the coin completes the circuit. Great. There's the wires. There's the battery. Where's the switch? Paul must have left me a banana. That's given me a really useful idea.
So, XP called me over to give him a hand with all the final bits and pieces, and now at last it's finally finished. So, please, will you put me out of my misery? Tell me what this is.
Just a moment, Sarah. You haven't told me what you found out yet. How did your experiment go?
Well, I found out that electricity can travel through some things, but can't travel through others. What did you find out?
I found out that electricity travels through a circuit. So, to light up a bulb, you need a power source and some wires and a switch to control the circuit.
I wonder how many bulbs you could light with one battery. Let's do the experiment.
All right, but first I present Security Crisp.
Security Crisp?
Yes, my battery-powered alarm and security device to guard my prawn-flavoured crisps from burglars.
And how does it work?
It's a simple circuit. The electricity travels from the battery there, through the flashing lights, through the alarm, down here, and on its way back to the battery there, it activates the walloper here.
What's the walloper?
Look, in the middle. If a burglar puts in his hand to try and get my crisps, he has to touch this thing here, which is connected to this switch, which completes the circuit, setting off the lights and the alarm. Then, while he stands there in amazement, the walloper comes down and wallops his fingers. Would you like to see?
I sure would. Now you're not going to get your own fingers walloped, are you, XP?
Of course not.